Hello students, today's agenda is to check homework. We'll be dividing by a binomial and you will be able to do 3.3. Today students will be able to divide a polynomial by a binomial with long division. We will also be proving the remainder theorem, and what the remainder theorem says is that when a polynomial f of x is divided by a linear polynomial x minus c, and I set it up in here, the remainder will be equal to f of c. And I'll show you what this means when we apply it with our long division. So what does that mean in terms of this? What this means is that, first of all, f of c refers to f of the opposite of whatever is being added or subtracted. So since this is adding 3, in here we will have to use f of negative 3. And what does that mean? It means that if I use, first of all, change the sign right here, and I substitute that into x for this polynomial, the result that I get, that's what I'm going to get as the remainder if I use long division or even synthetic division. In here we're going to be using long division, so let's divide and then check to make sure that I have the correct remainder. The other thing is that when you do that and you end up with 0, when you substitute and you end up with 0, that means that this is a factor of this and there is no remainder. So you end up with 2 factors when you're dividing. Okay, so before we check, let's divide. And when we're dividing, later on you're going to learn the same thing but with synthetic division. In here we're using long division, and so I'm just going to set up this inside. X cubed plus 5x squared plus 7x plus 3 divided by x plus 3. And so the first thing that you want to do is get this first term and divide by this term. And you can do it on the side if you need to. So x divided by x is x squared, and that will be what you're going to put up here. Since you're multiplying this by the divisor, you end up with a binomial. You are going to affect the second term, and so the answer x squared goes right here. It's not because it's x squared and x squared, it's just because you're being affecting 2 of the terms. Then you start multiplying like distributive property. So x squared times x is x cubed. X squared times 3 is positive 3x squared. And remember how we have to subtract in long division? We have to do the same thing in here, but what I recommend is that you just change the sign. By subtracting both, you use that distributive property, so you might as well negative times negative is negative, and the negative times positive is negative. I prefer to do that and just put the negative so that I don't forget that positive in here is not there anymore. Now x cubed and negative x cubed cancel each other. Remember that this is negative 3x squared, so positive 5 and negative 3, that's 2x squared. Now I bring down the other term, so plus 7x. And so, again, I'm going to get the first term, 2x squared divided by the first term in here, which is x. 2 divided by 1 is 2. X squared divided by x is x. So in here, I'm going to put 2x. And it's positive because positive divided by positive gives me a positive. Now I start multiplying 2x times both of these terms. 2x times x is 2x squared. 2x times 3 is 6x. But again, remember we subtract, so this changes to negative and this changes to negative. This cancel. And in here, again, this is negative, so positive 7x and negative 6x is just x. Bring down the last term, so plus 3. Again, divide x by x. X divided by x is 1. And I put it up here. Again, 1 times x is x. 1 times 3 is 3. But now we subtract. That means changing the sign. And so these cancel. Positive 3 and negative 3 cancel as well. So you end up with 0. When you have a remainder 0, that's when we say that we end up with 2 factors. Okay, 2 factors. But what if they were asking you, is this a factor? And they didn't want you to find this answer. That's the answer. But they just wanted you to find out if this is a factor of x cubed plus 5x squared plus 7x plus 3. Then all you have to do, and again, this has to be linear, okay? You change the sign of that, introduce it right here, and see if you get 0. And if it's 0, then it's a factor. If not, you're just going to find out what the remainder will be. And so let's try it to prove with the remainder theorem. Again, it's just saying that if you change the sign of this, insert that into f of x, meaning all the x's, we now know that the remainder was 0, so we're expecting here to have 0. So f of negative 3 means that we have negative 3 cubed plus 5 times negative 3 squared plus 7 times negative 3 plus 3. And so negative 3 times negative 3 is positive 9, times negative 3 is negative 27. For this one, we just bring down the 5 because we have to do the exponent first. And negative 3 times negative 3 is positive 9. In here, positive times negative is negative. 7 times 3 is 21 plus 3. We multiply this and just bring the rest down. 5 times 9 is 45. And bring down negative 21 plus 3. In this case, it's easier to add the negatives first and the positives with the positives. And at the end, we just subtract. Okay, so negative 27 and negative 21 gives us negative 48. Positive 45 and positive 3 gives us positive 48. And as you can see, negative 48 and positive 48 cancel each other, so you get 0. So we proved that the remainder theorem worked in here. Remainder 0, remainder 0. Okay? Okay, for number 2, the divisor is 3x plus 1, so we cannot really try to use the remainder theorem because this has a coefficient, okay? It's only when it's x and you're adding or subtracting something. But let's go ahead and use long division so that we can find out what the result is. And so we have 12x squared minus 8x plus 18 divided by 3x plus 1. Again, we get the first term inside divided by the first term outside. And so 12x squared divided by 3x gives us 4x. We put it right here. We multiply, and 4x times 3x is 12x squared. 4x times 1 is 4x. But again, we have to change the sign because we're subtracting. And this cancel. 12x squared minus 12x squared is 0. Negative 8x and negative 4x is negative 12x. Bring down the positive 18. Get the first term, negative 12x divided by 3x. And that's equals to negative 4. Negative 4 times 3x is negative 12x. Negative 4 times 1 is negative 4. We change the sign or subtract, so now it's both positive. This cancels, and positive 18 and positive 4 is positive 22. That's my remainder. So my solution, you're going to place it, since it's positive, you put plus. If it was negative, you put minus, and then put this divided by this as a fraction. So 22 over 3x plus 1. Okay, just put this over the divisor. And that's going to be my solution. And again, in this case, we cannot change with the remainder theorem because it's not x minus c. It has a coefficient right there. For number 3, we cannot use the remainder theorem because, again, we have a coefficient, but let's go ahead and use long division. So we have 14x squared minus 31x minus 14 divided by 7x plus 2. And so, again, we divide the first term inside by the outside, the first term outside, and it's 14x squared divided by 7x. That gives us 2x. We place it in the second term and start multiplying. 2x times 7x is 14x squared. 2x times 2 is positive 4x. However, we are subtracting is the next step, right? The first step is to divide. The second to multiply. And the third one is to subtract. And the last one is to bring down the next term. Bring down and start all over again. So we already divided, right? We divided 14x squared divided by 7x is 2x. We multiply and got this. Then we subtract. That's when we change the sign of both terms. And so these cancel. Negative 31 and negative 4x is negative 35x. Now we bring down, which is negative 14. Again, divide. We start all over again. Divide the first term here by 7x. Negative 35x divided by 7x. The x cancels and I just get negative 5. Now we multiply. Negative 5 times 7x is negative 35x. Negative 5 times 2 is negative 10. The next step is to subtract. That means we change the sign. If it was negative, now it's positive. It was negative, now it's positive. Negative 35 and positive 35x both cancel. Now in here I owe 14, but I paid 10. Now I only owe 4. And so the answer will be, let me write it up here. It will be 2x minus 5 with remainder of negative 4. So I just put minus the 4 above my fraction and just put this divisor or this one, which is the same. 7x plus 2. And that will be my answer with the remainder. For number 4, since we don't have a coefficient, yay, we can check with the remainder theorem. And the first thing that I want to do is to divide and then check with the remainder theorem to see that I do get the same remainder. And so x minus 5 goes out here. But now I want you to check because this is out of order. We need it in descending order. So we are going to put the x cubed first, then plus 2x squared, and finally minus 75. And so I start dividing. I didn't leave myself some space, so that's okay. The first term divided by the first term in here, and so that gives us x squared. So I put x squared times x is x cubed. X squared times negative 5 is negative 5x squared. Remember that the next step is, well, we already divided. We multiply. Then we're going to subtract. And then bring down. So by subtracting, it just means change the sign. If it was positive, it's negative. If it's negative, now it's positive. This cancels. And we have positive 2x squared and positive 5x squared. That's 7x squared. bring down the next one, negative 75. And again, we divide the first one by the first one. So 7x squared divided by x. 7x squared divided by x. And that gives us 7x. I put it in here. Now I divide it. Now let's multiply. 7x times x is 7x squared. 7x times negative 5 is negative 35x. The next step is to subtract. That means change the sign. And so this cancels. But in here, I noticed that this doesn't have an x and this one does. So they are not like terms at all. All I have to do is bring down this 35x and negative 75. Now I'm going to divide this first term by this. And so I have 35x divided by x. And that's 35. That was dividing. Now I'm going to multiply. 35 times x is 35x. 35 times negative 5. And positive times negative is negative. 5 times 5 is 25. Carry 2. And 3 times 5 is 15. And 2 is 17. Now we're going to subtract. And that means we change the sign. So if this is positive, it changes to negative. If this is negative, it changes to positive. This cancels. And then because I have a positive and a negative, I subtract and leave the greater sign, which is going to be positive. So I get positive 100. That's my remainder. So let me write answer in here. The answer will be whatever I get in here, which is x squared plus 7x plus 35, and then plus 100 over x minus 5, plus 100 over x minus 5. Now, do you want to check? Let's just prove the remainder theorem by placing f of c, which is f of positive 5. And what are we going to do with that positive 5? Remember that we changed this, and only when we don't have a coefficient, that's when we can use this theorem. We can use it to prove. What do we do with it? We change this sign and substitute the x. So it's going to be 2 times 5 squared plus 5 cubed minus 75. That's 2 times, remember that we always raise the powers first, so 5 times 5 is 25, plus 5 times 5 is 25, times 5 is 125, and just bring down the minus 75. 2 times 25 is 50, bring down the 125, and the minus 75. We add 50 plus 125, that's 175 minus 75, and that's equals to 100. So as you can see, we do have the same remainder. And again, if this remainder was 0 in either in here or here, what that means is that this is a factor and that you end up with another factor and no remainder. Okay, and so with the proof of this remainder theorem, we end our lesson. If you can please give us a thumbs up, subscribe around here. This is the link to the entire unit. This is the link to the entire unit, and here you will find the next lesson. Now you're able to do 3.3 and have fun.